Pose with the fans. Pose with the pose with the pose with the fans. Pose with the pose with the pose with the fans. Pose with the fans.
Hi guys, our topic today focus on compound interest based on chapter 3 and 4 from our MAT112 course.
Okay, now let's move into our first case study, which is compound interest chapter 3. Let's jump.
Is compound interest. Compound interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous period. Compound interest can be thought as interest on interest and will make the sum grow at a faster rate than simple interest, which is calculated only on the principal amount.
Now let's look into the methodology or the formula that is used in a compound interest. Let's start with the core formula for simple interest. S equals to P in the bracket 1 plus I close the bracket. Here, S stands for the future or maturity value. The amount you will have at the end of the P is the original principal. The amount you invest or borrow, I, is the interest amount. To find the actual interest earned, we use the formula I equal to S minus P. Now, to understand how interest is calculated over time, we need to know the interest rate and the number of period the money is invested or borrowed for. The interest rate per period is the nominal interest rate divided by the number of periods per year. For example, annually to 1, semi-annually to 2, quarterly to 4, and monthly to 12.
Now, let's look at question A. In question A, we are asked to calculate the accumulated amount that RAUB will receive at the end of 5 years. To solve this question, we need to use the compound interest formula, which is S equals to P, open bracket, 1 plus I, close bracket, to the power of N. P, the principal amount in this question, is 12,000 ringgit. I, the interest rate per compounding periods, is 0.0255, and N, the number of compounding periods, is 5. Now we already got all the values, we just need to substitute it into the formula. After we substitute, we are going to get S equals to 12,000 times open bracket 1 plus 0.0255 close bracket to the power of 5. Now we just need to use the calculator to get our final answer. The final answer that we will get is S equals to 13,610 ringgit and 5 cents. Now let's take a look at question B. Question B told us to find the total interest received at the end of the investment period. So how do we solve this question? We need to solve this question using this formula, which is I equals to S minus P. We already got the S from question A, so now we just need to substitute it into this formula. So after we substitute, we are going to get I equals to 13,610 ringgit and 5 cents minus 12,000 ringgit. And the final answer we will get is 1,610 ringgit and 5 cents. So now let's move on to question C. In question C, RAUB withdrew 3,000 ringgit after 2 years, and now we need to calculate how much would he have at the end of the investment period. To solve this, we need to list all the values first from the question. So P equals to 12,000 ringgit, P1 equals to 2, D2 equals to 3 years, the K equals to 0.0255, M equals to 1, the I equals to 0.0255, and now N1 equals to 2 and N2 equals to 3. Now we just need to substitute all of these values to the same formula again, which is S equals to P, open bracket, 1 plus I, close bracket, to the power of N. So we will get S1 equals to 12,000 ringgit, open bracket, 1 plus 0.0255, close bracket, to the power of 2. We will get 12,619 ringgit and 80 cents. The answer will be minus with 3,000 ringgit that RAUB has withdrew after 2 years. So 12,690 ringgit and 80 cents minus 3,000 ringgit, we will going to get 9,169 ringgit and 80 cents. So the 9,169 ringgit and 80 cents is our P2. So now we just need to substitute it into another compound interest formula again. So S equals to 9,169 ringgit and 80 cents, open bracket, 1 plus 0.0255, close bracket, to the power of 2. Now we are going to get 10,374 ringgit and 64 cents.
Now let's look into our final question for compound interest, which is question D. So the question is, after 4 years, the rate was changed to 4% compounded annually. Find the accumulated amount at the end of the investment period. Now, let's start. We are given that initial investment of 12,000 was made for the first 4 years. The investment earned interest compounded quarterly at the rate of 2.55% per quarter. So, using the compound interest formula, S1 equals to P1 in the bracket 1 plus K1 close the bracket in the bracket N1 close the bracket, where P1 is a 12,000, K1 is a 0.0255, while N1 is a 4 times 4 equals to 60. Now, let's solve this. S1 equals to 12,000 in the bracket 1 plus 0.0255 plus the bracket square root 4 equals to 13,271 and 62 cents. The amount of 13,271 and 62 now becomes the new principal for the next period. After 4 years, the rate is changed to 4% compounded annually, and the investment continues for 1 more year. Now we get the amount, but that is not the final answer. So we have to calculate again. So 13,271 and 62 cents in the bracket 1 plus 0.04 close the bracket square root 1. Now we get the answer for the total accumulated amount, which is 13,802 and 48 cents.
So, the end of the chapter 3, let's move to chapter 4, annuity. Let's go.
Now, let's move on to the next chapter, which is annuity. You guys must be questioning, right? What is annuity actually? So, annuity is basically a deal where you either pay money regularly to someone or they pay you regularly. It's all about a series of equal payments that happens over time. Imagine this. You buy a car with a loan. Let's say that you buy a car and take out a loan. The bank says that you have to pay 400 ringgit every month for 5 years. The monthly payment is an annuity because you are making the same payment, which is 400 ringgit for every month for a set period 5 years. So this is a case where you are paying an annuity. There is actually two formula for the annuity, future value and present value. Let's take a look at the future value first. So for the future value, we have S equals to R in the bracket 1 plus I close the bracket square root n minus 1 divided by I. Or we can use I equals to S minus R in the bracket n close the bracket. For the present value, we have A equals to R in the bracket y minus plus I close the bracket square root negative n divided by I. Or we can use I equals to R in the bracket n minus A.
Let's talk about our topic 2, annuity. Priced by a branded cotton at 70 for RN 73,800 with a 20% down payment. He take a loan from Bank Simpanan Nasional BSN to settle the balance at an interest rate of 4.6% compounded interest. He is required to pay equal monthly payment for 10 years to settle the loan. Question A. Calculate the monthly payment. R equal equation mark. K equal 0.046. M equal 12. I equal 0.046 divided 12. N equal 12 in bracket 10 close bracket. For A equals 73,800 minus in bracket 73,800 multiply 20 divided 100 close bracket. The answer is equal 59,040. Next, 59,040 equal R in bracket 1 minus close in bracket 1 plus 0.040 divided 12 close bracket square root minus 120. Then we divide 0.046 divide 12 and close bracket. Next, we put 59,040 in the top. 59,040 divided in bracket 1 minus in bracket 1 plus 0.046 divided 12 close bracket square root minus 120 and divided 0.046 divided 12 and close bracket. Therefore, the value of R obtained is 640 ringgit and 73 cents.
So for the question B, we have to calculate the total interest change. So we have to solve the question with formula I equals R multiply N minus A. So I equals 640.73 multiplied by 120 minus 59,040. I equals 4,127.60. So the total interest change is 4,127.60. So let's move to question C. After paying for 5 years, Faiz decides to settle the loan. Calculate the outstanding he has to pay. For the question C, we have to use the formula A equals R open parenthesis 1 minus open bracket 1 plus I close bracket by negative n all divided by I close parenthesis. We have to replace it to A equals 640.73 multiplied by open parenthesis 1 minus open bracket 1 plus 0.046 divided by 12 close bracket raised to the power of negative 60 all divided by 0.046 divided by 12. Value of A is approximately 30,893.45. Move to the last question. He fails to make the first 4 monthly payment. So how much he should pay to settle all the outstanding amount? For the last question, we have to use the formula S equals R open parenthesis open bracket 1 plus I close bracket by power n negative 1 all divided by I close parenthesis. We have to replace it to S equals 640.73 multiplied by open bracket open parenthesis 1 plus 0.046 divided by 12 close parenthesis raised to the power 5 minus 1 all divided by 0.046 divided by 12 close bracket. The final value of S is approximately 3,977.31.
In conclusion, both annuities and compound interest highlight the power of time and regular investment in growing wealth, while compound interest focuses on the growth of a lump sum over time. Annuities emphasize consistent contributions. Understanding both helps in making informed financial decisions and planning for long-term goals.
To summarize, our case study has shown how compound interest and annuity works in real financial situations.
We hope you found it informative and easy to understand.
Thank you for watching our presentation.
Thank you for watching. Bye bye.